Hi everyone, this is Vikas Singh Thakur, and in this video, we are going to see how we can get started with robotics in 2026. This video is 16th recording right now I'm doing here. So in the previous videos, I have forgot lots of point and there are lots of connection I need to put here in this video. So I really got it each and every time to help you guys. I really want to help you guys get a proper structure, how you can get started with it. Because lots of time we don't have a proper structure, and that's why we feel confused, and all the time we feel demotivated, and at the end we just quit doing it. So this is not just about a motivation part or to motivate you guys, but if you genuinely want to start with robotics, then there is lots of things you need to sacrifice in your life also. So without without this bhasha and all those, let's get started with it. So first thing first, robotics is a combination of lots of different fields. So AI, software, hardware, electronics, embedded, IoT. There are lots of things over there. So we are definitely going to divide into two parts. So first thing is the hardware, and the second is the software. So we need to get started with the software because there are lots of things. So if we are going to start with the software part, so first thing first, you need to learn a basic programming language. So for 2026 perspective, I definitely want or recommend you to go start with Python and C++. So the Python and C++, if you want to go with the software development in robotics, they are the very essential and very much essential programming language every roboticist needed to be aware of. And initially, you don't need to master each and everything I am going to discuss here. You need to get the basics idea of it, and over the time, naturally, I am honestly saying this thing is natural part. All you need to get is the basics. Over the time, when you work on a project, you are going to get that intermediate or little bit advanced over the time. So get the programming language done. So Python and C++, do some projects on top of it. So in Python, you can do computer vision, and there are lots of things you can do in Python right now. All the whole AI industries is going on top of these languages. So I definitely want you to work on some project. After that, the C++ part. So C++ is extensively used in the embedded part on lots of microcontroller are programmed using this language only. So let's say audio ID, if you are aware of it, so you can program this Arduino, and or the programming, or when you are building some real project or some starter project on using Arduino, then you will going to get a basic and some intermediate knowledge over that. So once you're done with the programming language, second is the framework. So in the framework, I will suggest try to learn Linux. So Linux is very essential right now. Each and every company in India, or in any robotics company, I could say, they are mostly targeting Linux. So in Linux, we have other framework like ROS. So Linux is an operating system, not a framework. But inside that Linux, we need to learn the ROS. So that is robot operating system. It is not an operating system. It is also a framework. So try to get the basics command on how different commands or terminal work in a Linux. So at the time when you get started with, you just need not to be like delete all your windows and put everything in a delete box or trash. You can have a virtual machine. Inside the virtual machine, try to have some command and have a hands-on experience on how terminal actually work, how you can manipulate different directories, files, and cell scripting, and lots of things are there. You can definitely explore it. There are lots of already YouTube channels who are working on basic Linux command, basic uh, get started with the Linux and all those. So you can go with it. So after this, the most non-negotiable part here is the version control. As I said, this version control, everyone know what I'm going to say. It's the Git or GitHub. So you need to get some basic commands, how you push, pull, how you create a repository, how you actually contribute on a repository. So if there is already a project, how you can contribute, how you can source their project, and how you can use those open source project out there in the GitHub. So this is very essential if you want to work on the software side of the robotics. So almost every software engineer are aware of this framework or the Git or GitHub. So I definitely want you to guys to learn some basics of it. You just once you get this, next step is to go with the ROS. So ROS is something it's very vast thing. If I want to talk about it, this video is not going to cover everything about it. So almost half of my year, almost 1 and 2 years, I have put my entire time into ROS, and that's how I get the intermediate, or and just at the basic surface of it. I have worked on SLAM, simultaneous localization mapping, some nav camera sensors, and different hardware fusion with the software. So ROS is very essential if you want to go with the robotics development, and lots of the careers. And if you want to have a career in robotics field, then this is a very essential framework you need to learn on. So once you are done with us programming language, some basic frameworks, and ROS is also a framework, but it is a very vast thing. You need to get everything bit by bit, and don't try to rush. Don't try to learn everything at the same time. Try to learn, go with each and every step by step. Because we have a limited time and limited lifespan, and when we are student, we have to figure it out how we are going to get a proper career and how we are going to do some really impactful project. So you don't need to be rushed, but you don't also need to be very slow. You need to put a lot of your time on this if you really want and genuinely want to start with robotics. So once you are done with the software part, next is the basic concepts like slam, inverse kinematics, forward kinematics. So these are very basics when you get started with robotics, and when you actually going to implement a robot, these topics are very essential. So slam, that is simultaneous localization mapping, and inverse kinematics, that is how you are going to uh, assign a particular robot arm to go to a particular path, a particular location or the coordinate by uh, putting its joint angle at particular degree. So inverse kinematic, forward kinematics, there are lots of other topics here. So you definitely need to go with each and every concepts and how this actually work here. So inverse kinematic, forward kinematics, control system, PID, that is proportional, integrated, and derivative. So this is a small concept where you find you some kind of motors and actuators to move to that particular location with that particular that accuracy or damping, lots of things. So try to just search about these things that I'm saying here: inverse kinematic, path planning, uh, PIDs. So these are very essential things if you really want to get started with it. And you can work on lots of different projects on top of it, because there is already existing projects out there. You can just source them, you can work on them, and over the time when you work on this, you're naturally going to get everything. Every path will be clear for you. So once you are done with this, go with the perception part. So here, perception, there are lots of new technologies already existing. Like you can use LiDAR, depth camera to pursue the external data or the external visual graphics, or we can say any visual data. So LiDAR is very basic if you want to get started with. So 2D LiDAR is there, like RP LiDARs, you know, there are lots of other companies all out there. So I have worked on the lab LiDAR. They use laser distance sensor, and just like ultrasonic sensing, but with 360-degree oh, freedom. So it can detect any flicker on 360 degree. So you can also target some very basic thing like in the perception side if you want to go with the OpenMB or OpenCV kind of thing. So OpenCV is an open source library where you can use the computer vision to detect some object. You can also do the detection. There is lots of other libraries inside this. So like Argo tag, April tag. So there are lots of other tools you can definitely explore here. So OpenCV is another thing, camera geometry, and how can you use triangulation and other concept here. So those are a very essential thing. Next is the depth camera. So depth camera is little bit next level topic, but I definitely want you to work on some DIY depth camera. I have already worked on it, and there is a video. I can put the link on the down, and you can check it out, and you can try making this video, that project by yourself. So once you're done with this, go with the machine learning part. So machine learning is also a very vast topic that I cannot discuss in this particular short video. So there are lots of concepts here. Just try to get the basics of it. Just try to have a basic machine learning, models. There are already lots of frameworks already existing there that you can directly deploy. Once you're done with this, next part is the hardware part. Well, this is the part where lots of us were afraid of. So in if we are talking about the electronics part, that is a very the first step for the hardware part. So in the electronics, you need to get the basics of resistor, capacitor, diode, transistor, how they work, what are their function, what they actually manipulate in a circuit, and how you are actually going to utilize their functionality in your project. So you can have you can see a lots of video already there, and even you can buy this small components. They are very cheap in market, and you can go with some basic project. You can search about those project in YouTube. And once you are done with this, try to have a small circuit, or try to build some touch sensor or some IR detector, some fire detector type of circuit. You can do all this basic project. So they will give you a basic knowledge of how they actually work, what are their actually functionalities out there. So don't try to go with those bookish way. Try to have a practical knowledge. Try to have those things in your hand and actually try those out. So that is what I definitely want you guys to work on. Then once you are done with the basic electronics, try to go with the PCB designing. So PCB designing, initially when you start with the resistors, transistor, capacitor, you use a breadboard. So if I show you what is breadboard, so this is a breadboard. You put different circuits on it. You put this jumper wires or the breadboard connectors, and you put different components on top of it. And based on that, you just test your prototype. And once you are satisfied that this prototype will work, you are going to work on the PCB designing. So PCB designing is also another field. So there is extensive different field like PCB design engineers out there. So they are definitely working on your, if you have seen your motherboard or lots of PCBs you would have seen in your life, like if you have ever opened your DHT or those TV setup box, so you have seen lots of circuitries in a green color book. So that is called PCB. So you need to work on that, how those work, how routing work, how you actually connect different parts, and how the circuitries, what are the different layer. And there are lots of concept on it. Just try to get the basics of it and try to have your own PCB design. There are lots of companies out there who could give you those PCBs manufactured. So once you're done with the PCB designing, next part is the most practical part. And here we actually going to see the output here. So in the real life, when we are talking about robotics, they are started with this point. So next is the embedded system. So embedded system get the most basic way how you get started with the embedded system is to get hands on the microcontrollers. So if I'm talking about microcontroller, lots of know what I'm going to say next. That is the Arduino. So Arduino is the most famous and most popular microcontroller out there, not just because it is was earlier, but because they have a great huge community that they are definitely going with you. There are lots of project already existing in YouTube channel. There are tons and tons of project you can work on. So get hands on with the microcontrollers, get a basic idea of how IDE work. And here is the place where you are actually going to see the main application of C++. And also you can use Python or try to have Python on your any type of, let's say, VS Code or any type of code editor you are working on. Have that Python on your system running. Try to uh, run both microcontroller and your system with synchronize with each other. Like you can work on a computer vision based tracking system where you control a servo motor or any type of DC motor using the computer vision. So here is the part where you actually going to see a real output, a real application of the all everything you learned over the past 1 or 2 months when you are following this particular path. So this is the place where you're actually going to learn a lot of things. And once you're done with a microcontroller like Arduino, so there are Arduino is a very basic, and if you want to go a little bit higher and go with a better capacity or better capable robots or any system, you need to go with the best other microcontrollers like ESP32 and STM32 is another board. So there are lots of microcontroller if you search for that, but these three are very essential if you want to get started with it. So Arduino, ESP32, STM32. So there are lots of things you can do with it. So once you are done with the microcontroller or the embedded system, you need to get hands-on on the sensors. So sensors are something that is going to give you an output data which you can process using microcontroller or any type of system you are using. So for example, and very known sensor, there are lots of known sensor. So like ultrasonic sensor, IS sensor, color sensor, and there is also the IMU, that is inertial measurement unit. So all these sensors are very interesting. You can search lots of them already existing there, and you can try to attach those sensor, try to integrate lots of system with it, try to do some fun project with it. So over this process, you will naturally going to get a lot of hands-on experience with different type of sensor, and over the time you will get to know how they actually work and what and where you can actually use those in which application you can use this sensor with. So once you're done with the microcontrollers or embedded system, you need to go and have a hands-on on the actuator part. So actuator is something that is actually going to move your robot. So it could be a DC motor, servo motor, stepper motor. It could be an QDD, quasi direct drive motors. There are lots of varieties of actuators already existing there. So if you are just a beginner, you want to get started with it, I would suggest go with a DC motor. So try to have a basic DC motor controller, or there is already a controller out there. So there are lots of drivers out there using which you can control this motor. So don't try to run everything using just the microcontroller. Over the time, when you search for those projects, you will naturally get the idea how you can actually control those. So try to have a basic idea of how this actuator work, how servo motor work, how stepper motor works, how can you integrate all this with a microcontroller, how can you control them, how can you use different applications here like OpenCV. You can use OpenCV. You can use a Python based script which can detect particular object, and based on that you can start some motor or anything you want to do. So there are lots of interesting projects. You can integrate everything: sensors, actuators, microcontroller, computer vision, uh, you know uh, lots of framework. You can integrate all everything together, and you can work on some interesting project over the future. So, and once you are done with this, and next thing is the simulation part. So here lots of simulation or the 3D designing software or applications already existing here. So if you want to get started with the 3D designing, or you want to simulate some a small mechanism, or you want to work on 3D simulation kind of thing, so you need to go with some basic tools like Fusion 360 is there, Onshape is there. So they Fusion 360 and like Onshape is and web based, so you don't need to actually download anything on your system. You can do everything through the internet. So that is a cloud based system. So you can go with the Onshape, or if you have good you know if you have good confidence that you can work on that, then you can go with the Fusion 360. That is also good software and application. I usually use Fusion 360 on my lots of project, so you can learn those. So they are very a basic kind of thing, and they are very easy to use. So at the time you will get the basics, and when you actually work on a project, you are going to touch some intermediate part. So this is about the different things I want to discuss about here. You are done with this concepts here. So all the best. This is all everything you need to actually know here up to this point. And I could say this is just a part one, because there are lots of things I haven't discussed here and in that much detail. But I will try to put each and everything on a particular a sequence way, so that in future you can just print those out and try to put that on your wall where you work or where you have or your working environment. So based on that you can follow those particular steps. So this is not a universal step. You can have anything based on your requirement, or based on your convenience, or based on your the resources you have. So if you have a proper laptop, that is very essential to have. So you definitely need to have a proper computer with you and a proper workspace where you can work on these different projects. So this is a good mindset practicing to have a proper environment around you, so that every morning when you wake up you need to get motivated that yes, I need to build something today. So have that is on your side. So this is all about this video, and if you like this video, please do like and subscribe and to this channel. And this is my first video that is being dedicatedly made here. So after this much time, this much trial and error on this video making, I definitely got the idea that how tough it is to build a YouTube video of this long. So this is my first try, and if there is something that I have said that is wrong, please do connect me on the description. I will definitely read and get a proper feedback based on that. And this is all about this video. So I am Vikas, and I love robotics. So see you on the next video. Till then, bye.